Good evening, everybody. I'm Anvesh Srivastav, and I will be taking you through the end-to-end functionality of this event management system. What this system basically does, it manages the product inventory and orders and the concurrent modifications to orders, and we can update, create products, similarly orders. All this will be hands-on. So let's dive right into it. So firstly, let's look at the project structure. So what the project structure looks like is we have loosely coupled components. We are following this loosely coupled architecture as this will help us in scalability, and whenever system failure occurs, they can be managed individually. So what we have is controllers, DTOs. DTOs basically stand for data transfer objects. I'll be walking you through how everything works, and we have exceptions. Mapper are basically used to convert an item to a DTO and vice versa. And we have models. Models will have order, item, and product. Similarly, we have repositories and some services, and this is our main inventory management application. So first, I'll just run this application to make sure we don't have any existing errors. As you can see that our application is successfully running on port 8080. So let's look to some of the controllers and other components. So what we have is our order controller. Order controller, this basically consists all the endpoints that are used to interact with orders. Like we can update get the order with ID, and we can get the list of orders, and also we can just create order. And in the product controller we have po post mapping, put mapping. All these endpoints are used to create orders, update order, delete our product, not orders, product. uh, we can, in this delete product, I'll show you that we are not actually deleting the product from the database. We just make it inactive. And making it inactive, what this simply means, it the product actually exists in the database, but it is just invisible. Like whenever you try to get the list of products, you won't be able to see it because it is it won't be involved in any orders or anything. And here we have DTOs. These don't really have any logic. This just helps us to give the information what the user actually wants, instead of sending the entire information to the user. So like we have these entities. Where are models? Okay, there, these are the models. So instead of sending all this information and interacting from the main model layer itself, what we have is this intermediary. We have these DTOs, so they can just hide our sensitive information, and whatever information the user want, we just deliver that information to them. And we also have custom exception handling. This is pretty simple. We just have custom exceptions for insufficient stock and resource not found, like if a product doesn't really exist and you're trying to get that. And any concurrent modifications, when they are used, you can just use these for handling different exceptions. Product mapper and order mapper, these just, as I told, that these just map the product to a DTO and gives all the necessary information to the DTO, and that is being represented or presented to the user. And here the item to item DTO, there here a DTO is converted to an item. So these are the vice versa functionalities. And we have the repository layer. This helps us in interacting to our Postgres database using Spring Data JPA. Spring Data JPA is just an API, Java Persistence API, that provides us the functionality to interact with the database for basic CRUD operations. And we don't really have to write any schema, so it does make our life as developers really easy. We have interactions with products and orders, so we have different interfaces, repository interfaces for those. And in the services package, this is where our main business logic lies. So when it comes to handling concurrent modifications, creating orders, deleting any order, getting any order, listing, getting the list of all the orders, and similarly products, find products, delete products. Everything lies in this product service and order service. So here, as I told earlier, that we follow this loosely coupled architecture. So we are not like implementing all these features in the controller itself. So like if we were to implement all these all this logic in the controller, then if any error occurs on the controller when handling those endpoints, then like we would have been performing the operation then and there itself. So instead of that, we have separated the concerns, and this actually helps a lot in keeping everything error free in a sense. And also we have some tests as well. We will be looking to these at the end. So let's start testing our application using Postman. So let me first just run the application again. And one more thing that DDO is responsible for is product validation. So we are not using validation in our repository layer because we don't want, like, we JPA does provide us with validation with all the schema and everything, but I feel like that generates a lot of overhead and load on the database. Like every time we enter something, we have to like the database has to ensure that all the checks are maintained, the uh, product SKU or names are consistent and everything. So we are not using validations in our database because the mapping and everything, we are not loading our database's functionality. And besides that, what we're actually doing is we use the validation in our DTO layer, like in the main application layer. Here you can see that the validation input validations for any products are done. So like this format will be used whenever entering any SKUs. So this is the format. Like if you enter anything besides this, it won't be accepted, and this is done to maintain consistency. Like we don't want product IDs to be any random number. We want them to be in a particular sequence or in a particular order to maintain consistency. And similarly, we have checks for name of the product, price, and quantities. Like they can't be really be negative, and we will get the digits of a price up to two decimals. And this also helps in being more specific about the prices of individual products. So let's check out the endpoints. So here we have quite a few endpoints. We have a create product endpoint. So let me show you. I've created a few products here, and let me clarify one thing. As you can see that I've used PROD003. So this is the SKU. This was earlier, and what now I did is I made it better because I feel like the more products we add, the more number of digits makes everything better. So I just changed the input validation. So will not be able to enter products like this. Now we'll have products like this. So this is a recent update. I'll just tell you guys. So let's add some products. Say we have 003. I'll definitely use my book again, so I'll just add new my bill book. The price is going to be the same, or let's say a little bit discounted as 80. The quantity remains the same. Okay, so let's create this. Should work fine. Okay, we have our product ID. As you can see that this product is also registered in our PG admin. Also we are interacting to Postgres database using PG admin. I'll make sure to mention it in the documentation. And let's say we have to update this. So I'll just update our recently added product instead of updating the previously added ones. New my bill book updated, SKU number 3, price. Let's reduce this to a little bit. 3 no 395. Quantity on stock 100. Let's say everything is updated. You can also check in the database. Previously it was 10 and now it should be 100 and everything is updated. Here it is. And also I also updated the SKU number. There isn't any redundancy. So let's get this product. We hit this, gives us my bill book. Delete a product. So in case of deletion of a product, we don't actually delete it, we just set the boolean active field as false. So what this does is it won't involve any soft deleted products in our list of products, and we won't be able to uh, consider them in our order list. So there's just that, but it will definitely exist in the database. So delete product, I'll just delete or make any of these true ones as false. Let's say watch, and product ID is 4. Product ID 4. Okay, no content, because we're just getting a success response. Like what we actually did is just update the active boolean field. So that's why 200 means is a success status code, HTTP status code. And for every request, we will get the respective success codes for a more informative response. And let's get the list of products. So as I mentioned that we won't get the false field ones in a product list, so I'll just verify that. You can see that watch is false, so we shouldn't be seeing watch in our list. PS4 my bill book. Okay, we don't have watch in our list, so it is working fine. And let's say we want to search for products, so even writing a few characters of our specific products would give us all the relevant results. In our case we will get 3, and if we write here say W, so we'll get this new bill book. We are not getting watch here as well because it is set as inactive, or like the field is false. And inactive, this just checks the validation constraints. Like as I mentioned, we will not be able to add any random number or random field to make our database inconsistent. So you can see validation failed for these values. Let's create an order. So I'll tell you, like, one test case might be that we are having two valid products which are in quantity, which are in stock, and this product 4 has 0 stock. So ideally this request should not work. So let's just test it out. See, it doesn't work because the insufficient stock for product watch. And if we just remove this and switch this to our current product 8, this will generate an order with the total amount for us, and we will be listed with whatever products we have ordered. We can also get our order. This order ID is 6. We can just enter 6 as the path variable and we will get our order. This is our latest order. And here we get the list of orders. Like we also use pagination here. So we'll have 10 entries per page. So we have 1, 2, 3, 4, all of these orders that we have placed. And creating order with insufficient stock, this I already mentioned it, but let's say we just rate, and we didn't have 10,000 units of 8th, so this also gives an exception. So here is all the working of the endpoints. Every endpoint works good, and we can also test, like we have a few tests written, so we can also check our tests. So these tests are written because like we made use of Mockito and JUnit for testing. This is provided to us by Spring Boot and Java, so we had to add some external dependency, Mockito dependency here, as you can see, and then we use these tests. So what these tests does is these mock the data for us. So here we are not directly contacting or interacting with the repository layer. We have a specific like other mock data which is being tested to test all the controllers and services. You can see that we have this product, updated product, and you can see test product. We have these fields for testing. So let's just test this out. As you can see, every field works fine, and we don't see any errors here. So I'll just go with one control order controller as well. Test pass 2, we don't have any errors in our controller layer. Similarly, let's check one more for our product service. See, we don't have any errors. Okay, so here is the entire functionality of, oh, I'll just show you the order table as well. We have the time of the orders and a total amount and the number of orders placed. So here is the entire functionality of our inventory management system. Thank you.